We're going to graph position versus time today, or D versus T graphs. Now, distance is going to be represented up and down on the y-axis. Now, things could go from up and down or left and right, any which way, but we're always going to have it represented as position up and down. So even our thing, we're going left to right in our story. So if we went from 0 to 20 meters sideways, that would actually go from 0 and then up to 20 meters on the y-axis in this graph. That seems kind of funny. Well, we got to do that because time is just always on the x. So time is always moving from left to right from 0 to infinity seconds. And so distance or position has to be represented on the y-axis. Even if we might not be going up, we might literally be going sideways. So that's something that's a little subtle, might be confusing for some folks. Whenever you title a graph, it's always whatever is being represented on the y versus the x. So we have position or distance on the y versus x, which is time on the horizontal axis. Okay. Now I'm also getting my scaling done here. And so what do we got? Well, on the position side, looks like each tick mark's about 10, yeah? Goes 0, 10, 20, 30, 40, 50 is the fifth tick mark there. And on the x-axis, we're going, looks like it's 0, 5, 10. So every tick mark is 5. 5, 10, 15, 20. And so I'm starting to write, I think I put the number 20 here, so I got to put that at the right spot. So let's see. Oh, got to move it over, right? 10, 15, 20. And where does 40 go? Well, 40 would go, oh, not over there. So 20, 25, 30, 35, and then 40 would go there. And then 45. So what would this tick mark be? All right, 2 over, that would be 50. So that's 50 seconds in the future from 0, the time of 0. And then we have positions going from 10 to 50. So I'm going to put one more in there. So 10, 20, yeah, third one would be 30. Okay, so that's just getting proper scaling. And I have y versus x, which is position versus time. So it's labeled correctly. I got my little units on the y and x axis. So here is a story. Curious George is going for a picnic with Curious Georgina. Oh yeah, Curious Georgina has hair. It's like blonde, but it's a little bit fading. Maybe dirty blonde. I don't know. But Curious George is going to start at 0. That's his coordinate. And then he's going to eventually move to another point or coordinate in space and time, 50 meters, because he's got to meet Curious Georgina. They're going to have a picnic later. So that's good for them. Curious George was off for a picnic with Curious Georgina. He was very excited. He walked from his home 5 meters in 10 seconds. So he's going to go forward 5 meters, right? That's what it looks like. And it took 10 seconds to get there. So not in real time. So you see what it looks like in the picture. Yeah, he's halfway between 0 and 10 meters. So he's going to go, right? It's kind of funny, but it's on the y-axis. His position will be 5 up. That's his position 5. And he went forward 10 seconds. So forward 5 meters and also forward 10 seconds in time, time being on the horizontal. But he forgot his lunch. As quick as a flash, he turned back around and went back for his spicy hot pateles. He went back to where he came from in 5 seconds. And it took him 5 seconds. So he goes from that 5 meters back to where he came from, means he goes back to 0. That's what it looks like. So he goes back to 0. So he's at the 5 meter mark and he's going to go back down to 0. I think it said he's going to do it in 5 seconds, right? Okay, so that's why we gotta make sure sometimes we double check, right? Reading comprehension. So he's supposed to go back at 5 seconds. So 5 seconds go by forward, and he goes back to the original position. Next part, he grabbed his bag and rushed back out the door. Not wanting to be late, he jogged 30 meters in 10 seconds. So he's gonna go from 0 to 30, right? And that's just gonna take 10 seconds. So he's literally gonna go, and this is gonna take 10 seconds. I'm almost literally taking 10 seconds. But Curious George is moving forward to the 30-meter position, and that's where he is. Well, what does that graph look like? Well, he's going to the 0 position up to that 30-meter mark, as we can see. And he's going to do that in a time of 10 seconds. So we've got to make sure we get the 30-meter mark correct first. Yeah. So I'm kind of matching it up where 30 meters is on the y-axis, because y-axis represents where he is, and x-axis represents how much time passed. So it looks like we're going from 15 seconds to 25 seconds, because it's 10 seconds forward in time, and then 30 meters up. Okay, that looks correct. Next part. Unfortunately, he tripped and fell and bumped his head. His head was really in a lot of pain. He laid there for 20 seconds. So, what happened at the 30-meter mark? Here we go. Oh, he fell down. Oh no. Oh, he fell down. It's really bad. He's just staying there. Oh, George. Where is he at? Yep, 30 meters. 30 meters. But he's not moving. What are we going to do? Oh, is he breathing? Oh, I'm nervous. Oh, no, no. Oh, CPR. Oh, help him. Okay, emergency. I gotta do it because it's emergency. Okay, sorry. I know, I gotta keep clean. Okay, we'll clean the desk later. Oh my goodness. Oh my goodness. So at the 30-meter mark, what did he do? 20 seconds went by, and it was just doing CPR over there. See the picture? So we didn't really change his position in space. We're just going forward 20 seconds in time, and so the graph looks horizontal because we're staying at that 30. Yeah, on the vertical axis it's 30 and it stays 30, so it'll stay flat if there's no velocity, it's not moving. But 25 to 45, right? Because he went 20 seconds forward in time, 25 to 45 seconds, but it didn't go up and down. He only went left to right because it went forward in time, but not in position. He then got up and traveled on at a rate of 2 meters per second for 10 seconds until he met Georgina, who yelled at him but forgave him when she saw the pateles. So, okay, 2 meters per second for 10 seconds. Well, I can tell you it's going to look like this. He'll move forward and move forward to the 50-meter mark. She will yell at him, oh no, but he'll give her the pateles and then they'll be happy. Alright, good picnic. Happy monkeys. Alright. So why did that work, guys? Why did we wind up at the 50-meter position, yeah? Well, the reason why it worked was if you use a equation distance equals rate times time, or distance equals velocity times time, you just plug in the givens. Now you can rewind it, go back and read it, but what the story said was that Curious George was moving at 2 meters per second. That was his speed or velocity. And 2 meters per second, that's how fast he went, and he went that fast for 10 seconds. So what is that? 2 times 10 is 20, right? The seconds cancel, right? And we get 2 times 10 and 20 meters. So since he started at the 30-meter mark and he goes forward 20 meters, right? Then we can just add 20 to 30. And we're going to do that here in the graph. But remember, we're going to go up from 30 to 20 to get to 50. So I'm getting that 50-meter mark. But then I got to remember I go forward 10 seconds. So I go from 45 to 55 seconds and from 30 to 50 meters. 30 to 50 meters up, and then over 10 seconds to 55 seconds. And that's what I draw in there. Okay? So now our position versus time graph for this whole story is done, and he's at his 50-meter mark, and hopefully they're having a nice picnic. So I'm going to resketch it down here. So, oh, look how much nicer it is when you do things digitally. So instead of drawing it out, okay, it's the same basic graph, goes up, down, up, flat, and up again. But this is just more accurate. But we're going to make a velocity time graph. So we're going to take a position versus time graph and then create a velocity versus time graph from that. Okay? That's our next level. Okay. And so what we're going to do is we're going to look at the first part of our trip, which took 10 seconds, right? So from 0 to 10 seconds, I'm going to go ahead and make those intervals, those dotted lines. From 0 to 10 seconds, then 10 to 15, and then from 15 to 25, and then from 25 to 45, because those were all the different parts of our story where he was moving at different speeds and different directions, so different velocities, okay? And so that should work out. See, the time axis is the same for distance versus time graph, or velocity versus time graph. Okay? It's all going to correspond to the same moments in time, but we're going to graph velocity on the y-axis. That's the only difference. So what I'm doing in here is I'm interpreting my position time graph a little more accurately. Right, halfway between 0 and 10 is 5. So yeah, what did he do in the first part of the journey? He went forward or up 5 meters in the graph up, and then he went forward in time 10 seconds. So that's up 5 and over 10. See that at the bottom? The slope of a distance versus time graph is velocity. So the slope of my position versus time graph is rise over run, or 5 over 10. 5 over 10 is half, so that means he was moving at a velocity of, or a slope of, 1/2 meters per second, or 0.5 meters per second. So he's going to gradually get up to that speed, right? But let's just assume that he's super fast at accelerating, right? So, I mean, To make it a little more realistic, I kind of drew it was kind of going up pretty quick though. But he was doing that for a whole 10 seconds. So he got up to that speed and he was basically at that speed the whole time is what the story is saying. So half a meters per second, okay, for 10 seconds. Now the next part of our journey is he's going back home, back to 0, right? So it goes from a position of +5 to 0. So it's going, you're subtracting 5. So it's -5 was the change, and it's happening in 5 seconds, from 10 to 15, right, seconds. So what is -5 over 5 is 1, right? -5 over 5 is 1, or -1, sorry. So we're going to find -1. Actually, let's just start writing all those in, right? We have 1 and 2 over there. We got -1, -2 over here. And so he'll have a speed of -1, and that only happened for 5 seconds. So I'm going to make a little transition, but we're finding that -1 mark there on the graph. And so he's going to change, right? He's going to, oh, I forgot my patellas, and he's going to take a quick switch to the other speed going in the other direction. And he's going at -1 meters per second for 5 seconds. Okay. Now the next part of his story, which we can read from the distance versus time graph, is that he went up 30 meters in 10 seconds. So we're taking the slope of the dt graph, the slope of the position versus time graph is equal to the velocity. So it's sloping upward, so it's an upward velocity. So if it's sloping up, I know that it's going to be a positive number, and so my velocity is going to be above 0 in my graph. Okay, we went forward 10 seconds because we went from 15 to 25. I can see that in the graph. And we went from 0 to 30, so it's positive 30. He's going forward. Forward is defined as positive. So 30 over 10 is a slope of 3 meters per second, and so that's a speed of 3 meters per second. And so my graph should go all the way up to 3 and then go across. And so I kind of draw it like, okay, so he didn't just instantaneously change speeds. So a little bit of time passed, but for the most part, over those 10 seconds, he went 3 meters per second. Notice the diagonal line is straight, it's a constant slope. Now after that, he stopped and fell and bumped his head. So he's actually going to have what? 0 slope, right? What was his change in position, right? He had no change in position, he wasn't moving. So he's got 0 meters of him changing position, but time went forward 20 seconds. So that's the slope. It's rise over 1. It's 0 over 20 seconds, which is the slope, and the slope is the velocity. So the velocity is 0. Okay? So a horizontal line on a distance versus time graph is 0 velocity on a velocity versus time graph. Now that happened for 20 seconds, so it went from 25 to 45 seconds. See that interval? So we got no velocity. But then we have forward velocity again. In fact, they straight up told us what the velocity was, right? The velocity was 2 meters per second. But we can see what the slope is in the graph too. It went from 30 to 50 once again. So it's positive 20 meters in the rise. There we go, 2 meters per second, right? 20 meters in the rise, and it's 10 seconds in the run. So it's 20 over 10. It's 2 meters per second, right? That's what they already told us. And so all we got to do on the velocity versus time graph is to graph it a nice horizontal line. Is what we're going to graph, right? Like how we've been doing. So it's going to be 2 meters per second for 10 seconds, because we already draw dotted lines to help guide us. So for that slope over there on the graph above the velocity versus time graph, which is the position versus time graph, we went up 20 meters and over 10 seconds. Isn't that nice? We'll just patiently wait for me to write that in my very messy penmanship. But yeah, he's going to go 2 meters per second. So I'm finding my 2 mark on the y-axis, and we're going 2 meters per second for those 10 seconds from 45 to 55 seconds. Okay, well that took me a while to do that. That is the velocity versus time graph. Notice we have positive velocities, and we also have velocities below 0 or negative. That means it's just going in the opposite direction, right? He went forward and he went backward. Now we have another rule here. The area under the velocity versus time graph is equal to your distance traveled. Okay? So Curious George had to backtrack, so he didn't just go 50 meters. He went forward and then he went backward and went forward again. So he went more than 50 meters of total distance. Okay? But when you look at the areas, if the areas are positive and negative, that's a different thing, which is just your displacement. And that just means from wherever I started to wherever I ended up is my displacement. So what was that in the story? He started at 0 and he ended at 50. So his displacement should just be 50. But his distance was more than 50 because in order to get to 50, he went forward and went backward again and went forward again. So it's going to come out different. So if I'm looking at my areas, areas are all these rectangles that are under the velocity versus time graph. So the first one here, right, it was half, right? So height of half, and then what was that? And it went over 10, right? So height versus width, right? The base was 10, and then the height was half. Then we got the other area up here, which was a positive one, and so that was a height of 3 and a base of 10 seconds, right? And then we had another one for 10 seconds over there, and then we had no area because it was flat in that other section, okay? So when we look at it, okay, we can get our areas, and I'm just going to punch them in. So the first one is half times 10, so that's what, 5. That's an area of 5, or 5 meters. That was the distance covered there. And so I'm going to go ahead and just type that in. And so, I mean, it's important. I think I would have put the signs in there too. Yeah, this was forward 5 meters, so it's plus 5 meters. It's important to type that in correctly. And then after this one, and I'm also color coding it red, which is good because I'm making all my areas red. So these areas are distances, okay? So plus 5 meters. And then the next one was what? -1 and then 5 seconds. So 1 times 5 is 5. So I don't know if I put a negative sign there, but it's got a magnitude of 5. That's how big the area is, 5. But it was negative, okay? The next one was 3 in height, and the base was 10. So 3 times 10, the area is 30 meters. And the last one was 2 meters up and 10 seconds. So the base was 10, right? The height was 2. 10 times 2 is 20. So we got 20 meters over there, okay? So what do we got? We got 5 plus 5 is 10 plus 30 plus 20. So that's a total of 60. So we got a total distance of 60. Why is it a total distance of 60? Because what happened in the story was he went forward 5 meters and he went backward 5 meters, right? So that was like 10 meters he went. And then after that, he was at home again and he had to go another 50 meters, right? So the total distance was he did 10 meters and then he went to Curious Georgina from 0. So that's 60 meters, right? Total of 60 meters of distance. That was the story. But the displacement, right, is going to be different because it's not just all absolute value of the areas. What we just did, everything in red, we considered it positive was distance. But displacement is positive and negative areas. So, yeah, think of distance as the total steps you went, but your displacement is how far from point A to point B. So we have a positive 5, right? But you see that second part of the journey was below 0. So I'm going to color code that differently, and I'm going to make it, I don't know, blue, right? I'm going to color it in. It's not a value of plus 5, it's a value of actually -5. So now we got the plus 5 area over there. It's going to kind of cancel with the -5 meters over there, right? So I'm going to put a nice little X through those two. The plus 5 and -5 are going to cancel. And so that doesn't contribute to my displacement value because they canceled. My displacement is I went 30 meters then 20 meters to get to 50 meters. And so that's my total displacement. That's my total story from point A to point B. And so the position versus time graph kind of tells you the same thing, right? Ultimately, we started at 0, right? That's where at 0 time, I was at 0 meters, right? But then at the end, at 55 seconds, I went all the way to 50 meters. And that's what my displacement was, okay? So I think I'm going to label it displacement in my nice position graph above here. So bear with me, I'm going to make it look pretty, okay? So I went from 0 position, right, on the Y to 50 meters. So my total displacement was 50 meters away. From 0 to 50 meters, and that happened from 0 to 55 seconds. So there we go, distance versus time graphs. Actually, more accurately, position versus time graphs, and velocity versus time graphs. I hope we learned a lot today. Aloha!